Question 1. Evaluate the force acting on a charge Q1 if the point charge Q1 is 50 microcoulombs and Q2 is 10 microcoulombs, are located at a vector position -1, 1, -3 and 3, 1, 0 meters respectively. Okay, so to solve this, first we want to summarize the questions. So we got Q1 equals to 50 microcoulombs, Q2 is 10 microcoulombs, and we know that Q1 is at a vector position -1, 1, -3, and Q2 is at 3, 1, 0. So we don't really need to draw this in three-dimensional. We could actually just draw 2 points. Let's say Q1 is here with a vector positions of -1, 1, -3. And then let's say Q2 is somewhere here with a vector positions 3, 1, 0. And they both, the vector position is with respect to the origin. Let's say origin is here. Okay, so we got a vector. This is my vector positions of -1, 1, -3. And this is the vector positions of 3, 1, 0. So we want to work out the force acting at the charge Q1. So we're going to do this by convention. So we normally draw a vector positions between 1 and 2. So this is my vector positions. Let's call it R. And then we define our force F2 and our force F1. So now we can work out the vector R between the charge Q1 and Q2. So our vector R is our vector here. Let's call this vector R2, and this we call this vector R1. So it's our vector R is basically our vector R2 minus our vector R1. Okay, so negative of our vector R1, meaning that this vector here, which is our minus R1 vector. So this is equals to our 3, 1, 0 minus our -1, 1, -3. And this gives us 4, 0, 3. And this is in meter. So next we want to work out our unit vector for R. That will be our vector R divided by the magnitude of our vector R. That will be 4, 0, 3 divided by the square root of 16 plus 9. This will give us 0.8, 0, 0.6. So now we can work out our force F2 which is equals to minus of F1. So our F2 is Q1 Q2 over 4 pi epsilon naught, the magnitude of r squared times our unit vector r. So F2 equals to 50 microcoulombs times 10 microcoulombs over 4 pi times 8.854 times 10 to the minus 12 square root of so it's the square root of 25 squared. That is 5. So that will be 5 squared times our unit vector, 0.8, 0.6. This will give us 0.144, 0.108 Newton. So that's the force F1, but we're interested in the force, sorry, that's the force F2, and we're interested in the force F1. Okay, so F1 is equals to the negative of F2. That will be minus 0.144, minus 0.108 Newton. So this is the solutions to question 1.